Hello, I'm Saitya Setipalli, starting the presentation on comprehensive housing price analysis of the San Francisco Bay Area. The region, with its large IT presence, has seen a significant increase in the number of residents over time, and as such, the housing prices have fluctuated heavily in this region. This provides us with a unique opportunity to analyze housing prices and housing trends, and also analyze and find out the features which are influencing the housing prices in this region over time. Our primary focus of study in this analysis is centered around three critical dimensions. We are interested in building a model which is capable of accurately predicting housing prices based on various features. Also, we would like to analyze market trends about how the real estate market is fluctuating over time and the various features which are important or influential in this change. Also, we would like to find out the factors which are affecting the housing prices, as these are the factors which house buyers are interested in or looking for when they're buying a new house. As such, our hypothesis posits that the housing prices are influenced by a combination of factors including location, property characteristics, social economic indicators, and various other factors which include geospatial as well. So, the dataset which we have utilized for this project consists of 20,000 samples and has been taken from the Zillow housing data. This is including various features like county, city, zip code, street address, price, bedroom count, lot size, building size, and year of construction. It also includes information on when these properties were sold and the geographic coordinates of the houses. Of all these, county, city, and street are categorical variables which have a defined class or are in textual formats. So these center are around a group of points. Well, zip, price, bedroom, LSQFT, which is lot size, and the BSQFT, which is the building size, year, longitude, latitude, are numerical values. After a preliminary analysis of the data, we have found that a good portion of these entries have missing values in them, and this is quite common with real estate data. So this provides us with a new opportunity to handle this missing data using various explorative methods which we have learned in class. To get a starting footing with this project, we have gone through various uh, scientific papers, and they have provided us with various approaches or methods to clean the data, analyze the data, and also have put emphasis on the utilization of multiple advanced machine learning algorithms for building out the predictive model so that it can be easy to do a comparative study between them so that we can understand which or whatever model is the most effective for predicting of the house prices. Also, they have provided us with various analytical strategies and metrics which can be utilized for analysis of the same. Next, I would like to pass over to Jayashankar for exploratory price analysis of the housing data.
Thanks, Saitija. I'm Jaishankar Mathapoti. Today I'm going to explain our exploratory study on the Zillow dataset that really helped us to predict the pricing ranges in the Bay Area. Given the dataset of Bay Area from Zillow Research, there are 20K entries with 12 attributes. Uh, every attribute has its own characteristics and properties that help us to minimize the error and generalize the model. As you see, there are 12 attributes. We divided them into categorical and numerical data. And categorical helps us to use the advanced algorithms like neural network to generalize the model and get the accurate output. And also we used numerical data on various algorithms like linear regression, SVM, XGBoost, and different algorithms. As you see, there are some missing entries for some of the attributes which are bedroom, square feet, year, and longitude, latitude. We applied different data cleaning techniques in order to remove and replace some of the attributes, some of the attribute values. Next section is preliminary observation. Before cleaning and processing of data, we did some analysis which helped us find out what kind of data cleaning techniques we could apply, or like how data is concentrated at one place, what are the different ranges of the data for each attribute, and what kind of correlation between each attribute. We were able to find that initial things by plotting them in the graphs. As you see, this red marks is clearly showing the outliers, how much data is a little bit extreme compared to the given data, other data samples. So we were able to find those things here. And coming to the data cleaning techniques we have applied, finally, mainly be focused on this thing. Mainly be focused on removal of outliers and the missing of replacing the missing data. So we started looking for extreme cases of outliers by plotting interquartile ranges. We found that 90th and 25th quartile range gave the best range, out of which we eliminated all of the outliers. and then we have eliminated missing values. We have replaced those missing values with the median, which is a metric which gave the maximum output from the model, as well as using different techniques. So it gives the major impact in our data cleaning. So next step is descriptive statistics. So we represented all the statistic metrics for all of the attribute values in order to know the characteristic and property of each attribute. It helps us to design and apply various techniques like feature engineering, using polynomial features, eliminating the overfitting and underfitting, handling the weight parameters and bias parameters. So in order to fine tune those things, model parameters, we got to know the relationship by using these metrics. Next one is data quality and consistency. So using this data cleaning techniques and other techniques, we were able to make the data consistent, and also using regularization and scaling factors. Also, we made all of the data represented in the same dimension and also in the same consistent manner, so that will easily generalize the model and gives the best prediction. So as you come in the data visualization, we have represented different visualization diagrams between attribute pairs, between attribute and prices as well. As you see, the top 10 expensive cities displayed in the green bars, and also you can see the major of the bedrooms are three, four bedrooms. We also see box plots which shows the interquartile range for each bedroom. And scatter plot, there are, if you see the number of all of the bedrooms are allocated at the same place, concentrated at the same place. And this is a scatter plot, which is it is a matrix of, it's a relationship between each feature, which we can know the best picture of all of the correlation between each feature. This is a line graph which gives the fluctuation of prices between 1800 to 2000. And this is a scatter plot which gives the county-wise average price, which obviously showing the Sonoma County has a high expensive price. And this is a heat plot which gives the latitude and longitude position with the price after removing the outliers. And this is as per the city-wise, which has the major expensive values. So by utilizing these advanced techniques of data cleaning, really help us for the feature engineering and trying out different algorithms, different parameters, finding out different correlation between attributes, and made algorithm more generic, and find out the trends of the market. That's what about this section. The next section is going to explain by the Ravi Chaprala. That's it.
Hi, I am Ravi and I will be presenting the inferential analysis part of the project. So after completing our exploratory data analysis, we moved on to inferential analysis to apply various statistical models to predict the housing prices. Starting with correlation analysis, we plotted a correlation matrix where we observed that price has a high correlation with building square feet and number of bedrooms. Coming to hypothesis testing, we wanted to check whether the number of bedrooms has a significant impact on the housing prices. So to test this hypothesis, we used one-way ANOVA, and it gave a p-value which is much smaller than the common significance level of 0.05. So the null hypothesis is rejected, and we concluded that the number of bedrooms indeed has a significant impact on the housing prices. Coming to confidence interval, we try to estimate the average housing price, and the confidence interval is calculated using z-test for mean. The 95% confidence interval for the average price lies within the range 607,000 and 617,000, or in other words, we are 95% confident that the true average price lies within this range. As we saw a high correlation between the square feet and the housing price, we plotted a scatter plot, and the regression line shows a linear relationship between the two. Coming to model building process, before starting the modeling phase, we made sure that we encoded all the categorical variables, and also we normalized all the numerical variables to avoid potential bias. And for this project, we chose a range of models, and as this is a regression task, we chose models like linear regression, random forest, support vector machine, gradient boost, neural network, and XGBoost. And to compare all these models, we used performance metrics like mean squared error and R-squared scores. And for our final model, after comparing all the metrics of all these models, the XGBoost proved to be the most effective model, outperforming all the other models. Starting with linear regression, after training the model and testing it on the test data set, it got a root mean squared error of 206,000 and R squared value of 0.47. And this is the residual plot where you can see the data points are not really close to the zero line. Coming on to random forest, we trained it using an estimator as 100, and it gave a root mean squared error of 161,000 and R squared value of 0.67, which shows a much better performance compared to linear regression. And this is the residual plot where you can see the data points are much closer to the zero line when compared to linear regression. And next, we trained the support vector regressor model, and it gave a root mean squared error of 225,000 and a R squared value of 0.37. And this is the residual plot for the support vector regressor, and you can see the data points are not really close to zero line. And from here on, Srivastava will take over to continue with the remaining part of the project. Thank you.
Warm greetings to one and all. Thank you for my teammates for continuing up till now. And I'm Srivastava. I would like to move forward with the other machine learning models that we employed for our study. So the first is gradient boost, which is one of the advanced models that we employed to optimize the results even better. And we got a root mean square error of 0.17 and an R squared value of 0.60966. So the residual plot for the model is depicted below. And moving on to next is we have neural networks, which is an advanced option that is being considered these days for achieving a good results and a definitive study conclusion. So when we employed this model, we got an root mean square error of 0.2 millions and an R squared value of 0.48. The residual plot is depicted below. And moving on to next, we have XGBoost, which is a advanced version of gradient boost, and we employed this and we got our results much optimized, and the results were root mean square error of 0.16 million and an R squared value of 0.68. The residual plot for this is depicted below, and on observing the residual plot, we can find the values are much more aligned towards the median line, and when we compare to other residual plots as depicted, we find this to be highly optimized. And this ends our inferential analysis part. And from what we performed in inferential analysis, I would like to make a few points that on comparing different models, we not only identified better performing models, but also gained an understanding on various features that are influencing the housing prices. So this comprehensive approach allowed us to address the initial problem that was defined in a very effective manner, and thereby demonstrating the power of data analysis for real estate market prediction. And from all the study that we have performed, I would like to conclude that on our comprehensive housing pricing analysis in San Francisco Bay Area, we were able to make some few critical statements, and one of them was the features such as square footage, bedroom, zip code, and latitude were identified as significant factors in influencing the housing prices. And on performing analysis of variance testing, we confirmed that substantial impact on the number of bedrooms was more on the housing prices. There are other factors such as geographical disparities and notable price surges since late 1980s, which are also influencing the housing prices. And of all the models that we employed, XGBoost emerged to be the most effective, and it helped in striking a balance between accuracy and complexity, thereby optimizing the model to the best possible extent possible. And these findings are also helpful to make a data-driven decision making. And in short, we would like to summarize all the models that we employed and the errors and R square values that we have achieved with each model. And on comparison, we can see that SVR had the least and XGBoost has the better optimizing performance, and thereby it has a better values. So from this, we can conclude that certain limitations are there in the data, such as addressing the missing data issues in different approach, estimation, exploration, additional features are not mentioned in the dataset. And considering such complexity and interpretability of XGBoost model, we have avenues open to explore some more future research and refinement of our analytical approach. And moving on to next, we have our citation here. So these are the references that we made. We went for these publications so that we took help from them in understanding the model, or taking which machine learning models to exactly employ to get the desired results. And in conclusion, we feel that our project provides a solid understanding of housing trends, offering an actionable insights for stakeholders and contributing to ongoing discussions about the dynamic San Francisco Bay Area housing market. We thank one and all, especially our Professor Rongpan, for able to work on such a dynamic project on comprehensive housing price analysis of San Francisco Bay Area using Zillow dataset. Thank you, one and all.